3.6, numerical methods. So we can use numerical methods to solve directly for the response of a system subjected to a forced vibration. Not the computationally most efficient method. However, can be quite useful, right? We have an ODE. Why don't we just solve the ODE directly, right? Why do we have to build these solutions when we can just solve an ODE? Doesn't that sound cool? Right? We have MATLAB. I think that was an answer on day one. How do you solve an ODE? And someone said Python. So, but we have MATLAB, right? So in MATLAB, ODE 45 is a very versatile ODE solver, right? So ordinary differential equations, we can directly solve it. And probably one of the first solvers you should try for most problems. It doesn't mean it's the best, but it's a good place to start, right? Good enough. So the solver is set up as Ty, so time equation equals ODE 45, your ODE function, your span, and your initial conditions. Where T span is from T0 to TF, integrates the system differential equation. Y prime equals F of Ty from T0 to TF with the initial condition Y naught. Blah. What does that mean? That means we need Y prime. So for us, we are going to create an equation where we have X dot on the left-hand side. It's going to be X dot equals this. And we have that, right? We have an equation in motion. We just have to move some things around inside of it. So the, sorry, we're going to do it twice. We're going to end up with X double dot of Ft minus Cx dot minus Mkx divided by M is the ODE solver, right? So if we look at our code 1 in MATLAB, this just looks like this. We set our T span from 0 to 10. We set our initial condition for X and X prime is 0. We have no displacement. We have no velocity. That works pretty well. And then we set up our ODE 45 solver, and we have our equation of motion, our T span, and our initial conditions. And then we extract the displacement and velocity, right? This is just kind of extracting those terms. And then we go ahead and we build out a function. And we set our mass, we set our damping, we set our stiffness. We unpack our state variables from the function before, from the loop before. And Ft is the forcing excitation. And that's our forcing excitation of function F. And then X double dot of T is just our equation of motion. Rearranged, so X double dot is on the left side because we don't write the Python rules, the MATLAB rules, right? We just have to follow what's given. And then we have dy dt equals X dot, X double dot, and we kind of unpack our variables. Now we have this force excitation function, right? And we could do it in our function. I just chose to do it in a different function because maybe you want to put different frequencies through this. And so I just have f of t equals 1/2 sine f of t equals 1/2 sine of 2 pi t. Pretty simple, right? Just a sine function, just some sort of sine function. And then I just hit run and it solves out a displacement. None of the knowledge we learned in chapter 3 is required. Yeah.
Is there like a function in Python to do that easier? I'm assuming there's like a numpy.
Yeah, well, what's the name of the Python function for ODE?
There is one, but it sucks. SciPy and IDP has
SciPy. Is it in SciPy? Yeah. Yeah, there's one native to Python. To be fair, when you say simpler, I don't think you're going to get any simpler than MATLAB's ODE solver. And I'm a huge Python fan. All of these figures, all of the code for the text is done in Python, but the examples are in MATLAB because from an engineering perspective, it's very good. And you can tell that engineers had a hand in writing the differential equation solver in MATLAB, and you can tell that chaos had a hand in writing that in Python, right? And I'm not actually saying, like, I think mathematically The Python ones are probably more mathematically correct, not correct, but more mathematically formulated. And the MATLAB ones are more engineering formulated. Because I always did it in Python. And then I did it once in MATLAB. I'm like, oh, this makes so much sense. And but it doesn't matter. I mean, an ODE is an ODE, right? The actual methods, it's just how you formulate it and put it in. Again, if I only knew one code, I would learn Python. But a lot of engineering firms use MATLAB, and Simulink, Simscape is very good in MATLAB. You know, there's other things you could use.
It's because Python's written by nerds when math language